Okay, one more video on going through some of these problems. Okay, these actually we're going a little bit backwards, but that's fine. Okay, coming up here, number one. All right, question is to find that angle x. Remember, you got a tangent here, you got a radius, they meet at right angles. Right angles, 290s, it's 180. With 60 is 240, leaves this angle here at 120. Okay, those are pretty straightforward. Over here, this angle here is 60. It's comprised of uh, two radii. Okay, so two radii means that, okay, we have at least an isosceles triangle, which means that this angle here is 60, which means basically we're dealing with an equilateral triangle. The central angle there is 60. Okay, the central angle is 60. All right, and what you have here is a tangent. So you have the right angle here, and that's 60. So you got over here 30. You got a 30, 60, 90 triangle here. Here's problem. You got a couple of these. We're going to kind of come back to those with right here. Okay. So with these kind of problems, what you got to do is you got to shift this distance between the two centers up parallel to itself. Okay. So that what we're looking at up here is a right triangle, because we take advantage of the tangent and the radius meeting at right angles. So what we have here is a right triangle. This uh, this portion that's been shifted up is the hypotenuse, that's 7. This side of the right triangle is the side we're after, x. This side of the right triangle is the difference between the two radii, which is 1 unit. So what we have then is, by Pythagoras, 1 squared plus x squared is equal to 7 squared, which says, okay, x is going to equal 49 minus 1. X squared is going to equal, x is going to equal the square root of 48, which you should realize becomes 4 root 3. Okay, up here, we look at this, we look at the right triangles that are formed between a tangent and a radius. Okay, and you tag that as 5, 12. You should recognize a 5, 12, 13 triangle. Pythagoras is going to get you through the rest of these. Here's a little bit of algebra between these two. Let's take a look at this. Okay, this length is x. It's the radius of the circle. The right triangle is right up here. So we have x squared plus 10 squared equals the hypotenuse squared, which is x plus 7. Okay, that's got to be squared. Don't forget, you got to FOIL that out by algebra. Okay, that becomes x squared plus 14x plus 49 equals x squared plus 10 squared. Looks like we'll lose the x squares. 10 squared is 100, is equal to 14x plus 49. That certainly you can figure out. Not a big deal. Okay, let's see. We're coming down here, looking at a couple of these. These are problems where when the chord is perpendicular to a radius, then the chord is bisected by the radius. Okay, so which means we've got the total chord of 24, which is being bisected into 12 and 12. It looks like we're looking at a 5, 12, 13 triangle. That'll get you through this. This one, this length is 2. Okay, this length is 2.5 because the AB is 5. So AB is 5. So this length is 2.5, and then you got your radius helping you form a right triangle right there. Okay. Going through those previous videos. Okay. I know we could look at a couple more here. These should not be that detailed. Okay. Let's look at number 3. It might be interesting. Okay. Um, so what we have here is we're looking for the arc X. The arc X is, okay, going to be we're going to have to look at the angle out here, which is 50, which is an exterior angle. So the exterior angle, which is 50, is equal to 1/2 the arc furthest away, which is 160, minus the arc closest, which is the unknown, which is x. Okay, double both sides, that's 100, is equal to 160 minus x. Okay, so I guess x is going to equal 60. X is going to equal 60. That's 60. Okay, so we got 160, another 60, that's 220, and that leaves this arc here, the rest of the circle, 220, 360 minus 220, that's 140. Angle Y is an inscribed angle formed by a tangent and a chord, which is half of that. So angle Y is equal to 70. Okay, angle Y is equal to 70. Let's try do one more. Okay, couple down here maybe. We haven't looked at these. Okay, here again. Here we have an interior angle. The interior angles are always vertical. Okay, so we're asked to find P, but P is 26x minus 2. Okay, so the angle P is equal to 1/2 the sum of the two arcs that it meets out with, which is arc QR and arc SD. Okay, so that's 1/2 of, okay, 131 plus 18x plus 1. And that 1/2 is equal to 26x minus 2. Okay, I'm going to avoid working with the fraction. I'm going to double both sides. It's going to give me 52x minus 4 is equal to 131 plus 1 is 132 plus 18x. You should be able to solve that. That's just a little equation for you to solve. Okay. Let's just do one last problem here. Angle D. Angle D is an exterior angle. Exterior angles are half the difference of the furthest arc, which here is RB, minus EC. Write down the formula. Once you write down the formula, just plug in the pieces you have and solve for what is asked for. So we say here, this is 5x minus 10 is equal to 1/2 of 13x plus 7 minus 60. Okay, so there we go. Let's not mess with any fractions. Double both sides. 10x minus 20 equals 13x. 7 minus 60 is minus 53. Okay, so there you go. Solve that equation. I'm going to shoot 53 over here and add it. That gives me 33. I'm going to subtract 10 over here. That gives me 3x. So I guess x is equal to 11. Okay, so there you have it. All right. Get ready for Monday's test.